Good evening, idiots. I've had a student not attend a lesson for my maths tutoring, so I've had a go at one of the past exam papers. Well, mainly this bit here. So this is question two of the 4038 CEM4 exams. I believe that's the second one on Aula. This shit's just common sense. So I'm looking at this mainly. 10 mark integration by parts question. We're trying to calculate the integral from 1 to 0 of x squared e to the x dx. And I'm just going to try and explain this to a point where Finley can understand. That's the main goal. So when you're dealing with integration by parts, if I'm just going to lob the formula back up here. So that's basically it's the inverse of the product rule. So you know how if you've got two things times together and you want to find the derivative of it, you take the one times by the derivative of the other, so that's u times v prime plus basically the opposite, one times the derivative of the other. So if we're integrating that, we're essentially going to integrate both sides of this. So I'm going to integrate this with respect to x, and I'm going to integrate this with respect to x. So this integral and this d by dx, they actually cancel out. That's a cool thing about calculus. Integrals and derivatives cancel each other out. It's like timesing and dividing, adding and subtracting by the same thing. They're just going to cancel each other out like that. So this side, we're just going to be left with uv. And then we're going to have this. If we just integrate both of them, it's literally just going to look like this. So it's going to be integral of uv prime dx plus the integral of v prime dx. But we've got two integrals. We're just looking at one thing. So we're just going to subtract this one on the bottom. So we're going to be left with the integral of uv prime dx is equal to uv minus the integral of vu prime dx. And this is integration by parts. It's basically just the product rule, but backwards. You're actually given that formula. There it is in all its glory. I've just done it. I've just shown where it comes from, derived it, so it makes a bit more sense. So you may notice we've got two functions times by each other. That's usually when you use integration by parts. But because it's in a different form, it's not the integral of uv we're looking at because of how this shit's cancelled each other out. That's where this comes from. So we need to decide what do we make our u and what do we make our v. Because depending on which way we do it, it's a lot easier way to do it round. So I use the acronym LIATE or LATE, depending on if you want to piss around with inverse trig or not. And this is just basically a priority order for what we set u to be. Because u, we want to be, we want v, the other way around, to be easiest, because we've got to essentially set this, because this is the derivative of v, which is actually in our integral. It's not uv we're looking at. We're going to have to differentiate one and integrate the other. So this is just basically which way round is it going to be easiest to integrate the other term. So like exponential is easiest to integrate, then trig, algebra, inverse trig, and then logarithms. So these shit's absolute hell to try and integrate. So that's why we do it like this. So this case, algebra, that just means there's literally just an x to the power of summate. That's this x squared term, and then e to the x is an exponential. So algebra is above an exponential. That's why I've let my u equal x squared and my dv equal this e to the x dx term. So I'm going to differentiate this to get the du is 2x dx. And I'm going to integrate this to get that v is just e to the x. uv is my x squared e to the x, and that's being evaluated from 1 and 0. And then this v u prime dx is basically just what we've not had. What have we had to change from this original integral? So we didn't have this 2x term and we didn't have this e to the x term. Well, we did have this e to the x term, but I've let this, because derivative and integral of e to the x is just e to the x, it kind of just throws everything off. So, bosh, there we go. I'm going to evaluate this. So I'm going to sub in 1, sub in 0, take them away from each other. So I've got 1 squared times e to the 1, which is just going to be 1 times e. So I've got e And then 0 squared times by e to the 0 is just going to be 0 times by 1, so 0. So this shit just becomes e. And because I've got a constant of 2 here, you can pull that out. So I've just got 2 lots of the integral from 1 to 0 of x e to the x. In the exam, it wanted you to do this as part A. I'm just doing this all as one question, which is one massive 10 marker, just because it's actually not that bad. So we've now got e minus 0, so just e, take away 2 lots of the integral from 1 to 0 of x e to the x. So same logic. Look at our Lie 8. What's before what? We've still got algebra and exponential, so x is still going to be our u term, e to the x dx is still going to be our dv term. So differentiate x, you just get 1, so it's going to be du is dx. Integrate e to the x dx, you just get e to the x. So again, same thing. We've still got this e term from this bit here, so we're going to put this to the side, and then we're taking away this, we're basically timesing this integral by a factor of -2. So I've pulled that out. Our uv is just x e to the x, which we're evaluating from 1 to 0. And our resulting integral is v du, which is just e to the x dx, which is just itself. So that's really easy to evaluate. So again, this is me just subbing in my 1 and 0 from here. So I've got 1 times e to the 1, so I've got e here. And I've got 0 times e to the 0, so that's 0 times 1 or 0. So I've still got that is just going to come out to e, even though it's x to the 1, not x squared. Because it's 1 we're dealing with, it still just comes out as e. And then we've got minus the integral from 1 to 0 of e to the x dx. So you integrate e to the x, you just get e to the x. That's the cool thing about that number e. And then from 1 to 0, you're going to have e to the 1, which is going to be e, minus e to the 0, which is 1. Because, well, why is that 1? Well, it's because anything to the power of 0 is 1. So we've got e minus 1. But because we're timesing it by a negative, that minus 0 is going to go. So we're going to have e minus e, which you're actually going to cancel out, which is pretty nice. Then we've got minus 1, so plus 1. So this whole integral basically just comes out as 2. Yeah, so we've got e minus 2 or 0.71828. And that is 10 marks in the exam. You just have to do that 4 times and you've bloody passed. Not that difficult, lads.